Alright, today in this video I'm going to be talking about route filtering, and in another video I'm going to be talking about redistribution of routes. So route filtering will play a major part in route redistribution. Now what route filtering is, it is the process by which certain routes are not considered for inclusion in the local routing table, or it's not advertised to one's neighbor. So there's kind of two different ways of filtering. It's one, I don't even know about it at all, or two, I know about a route, but I'm not going to tell it to my neighbor. So in that sort of logic, I am filtering routes in one way or another. Now, route filtering is important for BGP, which is used on the global internet. It is used in a variety of reasons. So route filtering, you can set BGP attributes. You can change them. You could accept certain BGP attributes, and then you could also reject certain BGP attributes. Now, there are two types of filtering. There is input filtering and output filtering. And this is where the previous slide said you can either know about that route in your routing table and not advertise it to your neighbor, or you can not know about it at all. So not knowing about it at all is input filtering. So input filtering, a filter is applied to routes as they are learned from a neighbor. A route that has been filtered out is discarded straight away, hence not considered for inclusion into the local routing database. So that is what input filtering is. Output filtering is a filter is applied to routes before they are announced to a neighbor. A route that has been filtered out is never learned by a neighbor, and hence not considered for inclusion in the remote routers database. So let's say I learned 5 routes and it's in my local database, but I'm going to filter 3 of them and only advertise 2 of them to my neighbor. So that is an example of output filtering. Now, why do I need to filter? Well, there could be some economic reasons. If you are an enterprise just like this and you are multi-home to multiple ISPs, ISP1 right here, he's going to advertise some routes to you. And then if you have a relationship with ISP2, you may advertise those routes to ISP2. So now ISP2 knows how to get to ISP1 and he's going to go through you. That is not a good idea, because now you, as just a campus network or your enterprise network, internet traffic is going to be flowing through your router to another ISP network. So that's not good. So you would want to filter. So ISP routes that he's sending you, you would filter them so it's not advertised out to ISP2. So that's that reason. Security reasons. So an ISP will typically perform input filtering on routes learned from a customer to restrict them to the addresses actually assigned to that customer. So the security portion of this, and there could be other types of reasons, but from the security standpoint, let's say I have my home network here and I'm actually going to start advertising routes to my ISP. Well, my home network, I'm allowed to use private address space from RFC 1918, and let's say I'm trying to advertise the 10.0.0.0/8 network to my ISP. Well, the thing about this is my neighbor could also be running the 10.8.8.8 or 10.0.0.0/8 network as well, and let's say he's trying to advertise that to the ISP. That's those addresses, those private address spaces, they are not allowed to be routed on the internet. So what the ISP should be doing is should be automatically inputting a filter to filter out those private address spaces, and that's what I'm talking about here. And also, what happens if I'm hijacking someone else's IP address and I'm trying to advertise that to my ISP? My ISP should know what IP addresses are connected to that interface, which is to me, so that they will only accept route updates from what I'm supposed to have. So that gets rid of address hijacking. Now, for some technical reasons, routers may not have insufficient or may not have the sufficient amount of memory. So what that means is if I was to hold the full global routing BGP table, right, probably has 600, 700,000 routes in the global routing table. Can my little Nexus router, I'm sorry, not Nexus, Linksys, my little Linksys or D-Link router or my Netgear router, is that able to hold the entire global BGP table? No, of course not. First of all, I don't even think those routers can support BGP, but I was just trying to use that as an example. But even if you do have, like, a 2900 series, maybe even 7200 series router, can it really support the full BGP table? Maybe or maybe not. So if your ISP is trying to advertise the entire global routing table to you, your router is not set up to handle it. So what you would do is you would actually set up a filter to only accept the routes that you need. All right? So those are the reasons to filter and what route filtering is. In another video, I'll actually show you how to filter it using either a route map, a prefix list, a distribution list, which all use access control lists, and then I'll even talk about route filtering as well. So I hope this was informative for you, and I'd like to thank you for viewing.